What if your next 100 YouTube shorts created themselves, all from a single sentence? YouTube shorts can drive massive traffic, but creating them manually is a grind. Scripting, voiceovers, visuals, editing, all by hand. Today, I'll show you how to automate the entire process with AI using n8n. Here's what you'll be able to create automatically from a single sentence.
The truth about climate change is happening faster than we thought. Rising temperatures, extreme weather, and melting ice caps are just the start. But there's still hope. Small actions like reducing waste and using clean energy can make a big difference. Are we ready to act before it's too late? Share this to spread awareness.
Everything you just saw was 100% AI generated using this exact automation. By the end of this video, you'll know how to build it yourself, even if you've never used n8n before. Before we dive into the details, here's what you'll need to follow along and build this automation yourself. n8n, the automation platform that ties everything together. Free to get started, with cloud plans starting at $20 per month. OpenAI, to generate the script and image prompts. Typical cost is around $2 to $10 per month if you create shorts regularly. 11 Labs, to generate natural-sounding AI voiceovers. Plans start at $5 per month. Replicate. This powers the AI-generated visuals and video clips. Each 6-second clip typically costs between 50 cents and $2, depending on the model used. Creatomate, the automated video editor that combines everything into a polished short. Plans start at $41 per month. Cloudinary, used to temporarily store the audio file. There's a free tier with 25 gigabytes of storage and bandwidth. Zero Code Kit. This handles some of the Python logic to keep the automation running smoothly. Plan around $5 to $10 per month for this. Important note, this is a learning tutorial. The goal isn't just to copy-paste, but to understand how everything connects. Once you see the structure, you can adapt it. Swap tools, cut costs, or add features. It's not the cheapest way to make shorts today, but it's fully automated, and AI costs will drop. The real value? A scalable content engine. Less editing, no pricey agencies, more consistent output. You won't watch this like an entertainment video. You'll pause, build, and revisit key parts. To make it easier, this video is time-stamped. Check the description to jump to what you need. Before we dive into the details, let's zoom out. This automation is made up of 6 major steps. The core process from idea to finished video, and 23 individual nodes inside n8n, the building blocks that make it all happen. Once you see how they fit together, the whole process makes sense. Here's the 6-step overview. Step 1. Create the video script. Generate a compelling script with AI. Step 2. Generate the AI voiceover. Convert the script into a natural-sounding AI voiceover. Step 3. Generate AI images. Create visual elements for the video. Step 4. Convert images into AI video clips. Transform the still images into short motion clips. Step 5. Prepare for Creatomate. Combine all elements into a structured video template. Step 6. Final render with Creatomate. Automatically generate the finished video. Let's build this together. Every node has its own settings, and one small mistake can break the automation. To save you the frustration, grab the fully configured n8n workflow. Link in the description. Here's my advice. Download it, open it on a second screen, and follow along. This way, you'll avoid mistakes, understand how it works, and gain the confidence to tweak it yourself. But don't just copy-paste. Stick with the video, make adjustments, and experiment. That's how you truly master automation and create workflows that fit your needs. To kick off the whole process, we'll use a simple n8n form where you can enter your video idea. This triggers the workflow. No need to manually start it inside n8n. Before we go node by node, here's a quick look at how to add nodes to your workflow. There are 2 ways. First, click the big plus button in the top right corner of the screen. Or click the small plus button at the end of an existing node connection. Then just search for the node name. For example, HTTP request, and click to add it. You only need to see this once. From here, we'll focus on what each node does and how to configure it. Here are the exact nodes we'll use to build this. n8n form on new n8n form event. OpenAI message model. Edit fields set. HTTP request. Split out. Wait. Aggregate. Merge. We'll now go step by step and break down what each node does and the exact settings you'll need. Let's start building. Step 1. Capture the video idea. Node type. n8n form on new n8n form event. The automation starts by capturing your video idea, the topic for your YouTube short. This node creates a simple input form. Every time you submit an idea, the automation starts automatically. Here's how to configure it. Set the form title to Submit your video idea. Set the form description to This form feeds directly into your n8n automation. Next, add a form field. Set the field name to idea, all lowercase. This is important because n8n is case sensitive. If the field name doesn't match exactly, the workflow won't work. Set the field type to text and add a placeholder like. Enter your short video topic here. Finally, make the field required. With that, you have a working input form that feeds your video idea directly into the workflow. Step 2. Generate the video concept. Node type. OpenAI message model. This node takes the video idea from the form and turns it into a complete concept, with a title, description, and script. After adding the node, connect your OpenAI API key. If you haven't set that up before, click Create New Credential inside the node and copy your API key from platform.openai.com under API keys. In the model field, set the model to GPT 4.5 or GPT 3.5 if you want to save costs. Next, paste in the system prompt. This defines exactly how OpenAI should generate the output. The prompt includes clear formatting instructions. It tells the AI to generate a short, curiosity-driven title, a description with 2 to 3 hashtags, a script broken into an intro, a fast-paced base, and a clear call to action. After the system prompt, click Add Message and set the role to user. This is where the video idea from the form gets passed into the AI. For the user message, make sure to use the exact expression as shown on the screen. This pulls the right data dynamically, ensuring the AI works with the correct inputs. Finally, scroll down and turn on output content as JSON. This ensures OpenAI returns properly structured data for the rest of the workflow. Click Test Workflow, and you'll see OpenAI generate a full concept. Including a curiosity-driven title, a short, engaging description with hashtags, and a complete script with intro, base, and CTA. With this step, you now have the full creative blueprint for your short, fully automated. Step 3. Combine the script parts. Node type. Edit fields, set. This node combines the script parts into one complete text block, so it's ready to send to the voice generator. Switch to manual mapping. Create a new field called message.content.script. In the value field, open the expression editor and select the intro from the OpenAI node, then the base, then the CTA. Place a space between each part. This merges everything into a single script, formatted and ready for the next step. Rename this node to Merge and Format Script so the purpose is clear. That's it for the first major step, creating the full video script using AI. Next, we're moving into part 2, generating the AI voiceover. Before we continue, make sure to download the exact workflow template, link in the description. I'll walk you through step by step, but some prompts and settings might not be fully visible. And getting them right is crucial to avoid errors. So grab the template, follow along, and double-check every detail to ensure your workflow runs smoothly. Next, we turn our script into a natural-sounding voiceover using 11 Labs. Node type, HTTP request. This node connects to 11 Labs text-to-speech API. Set the method to post. For the endpoint, use the 11 Labs URL for generating timestamped audio. Make sure to replace the voice ID with the one from your 11 Labs account. This determines the AI voice used. The with timestamps. Part of the URL is critical. It tells 11 Labs to return both the audio file and a list of timestamps, showing exactly when each word is spoken. These timestamps will be crucial later when syncing visuals. Under headers, add name. Name xi-api-key. Key value, your personal 11 Labs API key. In the body, send a JSON object containing the script text we generated earlier. Set the voice generation model to the latest multilingual version for the best quality. Once everything is set up, click Execute Node to test it. If successful, 11 Labs returns two things. First, the voiceover file. Second, a list of timestamps showing exactly when each word is spoken. The next step is to split the script into small 6-second segments and make sure each segment lines up perfectly with the audio. This is important because the AI video generator we'll use later works best with 6-second clips. That means the text, voiceover, and visuals all need to stay in sync. n8n can't handle this kind of advanced processing directly, so we send it to a tool called Zero Code Kit. Zero Code Kit is a cloud service that lets you run Python code inside your automation. The exact node type is HTTP request. The method is set to post. The URL is the one shown on the screen. This is Zero Code Kit's Python execution endpoint. Under headers, add authorization and enter your personal Zero Code Kit API key. You can find your API key in your Zero Code Kit account. In the body, set the content type to JSON. Add a field called code. This is where the actual Python script goes. The Python script does a few critical things. It takes the voiceover, alignment data, and the full script. It splits the script into perfectly timed 6-second segments. It pairs each segment with its exact timestamps from the voiceover. The result is a structured list. Every clip has a matching section of script, with the exact timing needed to generate matching video clips in the next steps. If you want the exact Python code used in this node, you can download the complete workflow linked in the description. Once this node runs, we have perfectly timed 6-second chunks, the building blocks for the final video. Next, we need to split those chunks into individual items so they can be processed one by one. For that, we use the split out node. This node takes the list of script segments created by Zero Code Kit and splits them apart into individual items. This is critical because n8n processes workflows item by item, so each segment needs to flow through the rest of the workflow on its own. Here's how to configure the split out node. Set fields to split out to result.data. This is the field where Zero Code Kit stored all the segments and their timestamps. Set include to all other fields. This keeps other useful data, like the original audio file, attached to each split item. With this step, each piece of the script is now ready to move through the workflow separately. That finishes step 2. Generate the AI voiceover. Next, we're moving into high-level step 3. Generate AI images, where we'll create the visuals for each script segment. Before we move on, I'd love your feedback. This is the very first video on this channel, and I want to make sure it truly helps you. If you're finding this valuable, tap like and subscribe. It lets me know to create more like this. And if you have thoughts on what's great or what could be better, drop a comment. Your input helps me improve and make the next videos even more useful for you. For the next step, we're adding another OpenAI message model node, this time to generate visual prompts. These prompts describe what the first frame of each 6-second scene should look like. They guide the AI image generator later in the process. This node works a lot like the previous OpenAI node, but there are a few key differences. So let's walk through the exact setup. First, in the node settings, make sure the resource is set to text and the operation is set to message a model. In the model field, set the model to GPT-4 or GPT-3.5 if you want to save costs. Next, we add two messages, one with the system role and one with the user role. For the system message, paste in the full visual prompt generation prompt. This defines how the AI should create the image prompts. As mentioned earlier, you can access the full prompt by downloading the exact n8n workflow. Link in the description. The key point is that this system prompt tells the AI to describe simple, visually striking frames. Things like landscapes, objects, close-ups, and POV shots, and to avoid complex human poses or fast movement. After the system message, we add the user message. This is where we give the AI the full context, both the entire script and the current 6-second segment it's working on. This is done with a few expressions, dynamic references that pull data from earlier nodes. Here's exactly how to configure the user message. First, type this line. Here's the full script. Right after that, insert the expression you see on the screen. This pulls the complete script that was combined in the merge and format script node. Next, type, here's the current scene. Then add script position and script portion, as well as the expressions seen on the screen. This inserts the current 6-second script segment, the exact piece that needs a visual and the ID number for this specific segment. This isn't strictly necessary for the prompt itself, but it can help with debugging if anything goes wrong later. Once both messages are set, the system message with the prompt guidelines and the user message with the actual script data, scroll down and make sure Simplify Output is enabled. Output content as JSON is enabled. With this setup, OpenAI will generate a clear 240-character image prompt for each 6-second segment, all tailored to the exact script and visual style we want. That finishes this node and brings us to the next node, generating the actual images based on these prompts. The next node is called Request Image. Node type, HTTP request. The request image node sends our visual prompts to Replicate, which generates the final images for our video. Set the request method to post and use the API endpoint seen on the screen. Flux 1.1 Pro does not require a version ID. Instead, we reference the model's API page, and Replicate uses the latest version automatically. Under headers, add authorization, bearer plus your Replicate API token found in API tokens. Content type, application/JSON. Prefer, wait, keeps the request open until the image is fully generated. Under body, set body content type to JSON. The request includes prompt, the generated image description from the previous node. Input settings. The aspect ratio is 9:16 to match YouTube Shorts. Once triggered, Replicate processes the request and returns a link to the final image. Since image generation takes a few seconds, we add a wait node to pause the workflow for 10 seconds. This ensures the image is fully generated before we proceed. You can adjust the wait time if needed. With the wait in place, we're ready for the next step, retrieving the final AI image. This step makes a simple GET request to fetch the image from Replicate. For the request URL, we use json.urls.get from the previous step. This dynamically pulls the correct image. Set authentication to none. Under headers, add an authorization field. Set the value to bearer followed by your Replicate API token. No query parameters or body are needed. Disable both. Once this runs, the AI-generated image is retrieved and passed to the next step. With this, step 3, Generate AI Images, is complete. Now we move on to step 4, Convert images into AI video clips. The Turn Image into Video node, an HTTP request node, generates an AI video using the Minimax model hosted on Replicate. Set the request method to post and use the API endpoint seen on the screen. In the headers, add authorization with bearer, plus your Replicate API token, content type as application/JSON, and prefer set to wait to keep the request open until the video is fully processed. In the body, set the content type to JSON and switch to expression mode. The request includes the structured video prompt, the AI-generated image from the previous step as the first frame, and prompt optimizer set to true for better consistency. Once triggered, Replicate starts processing the video. This can take anywhere from 2 to 10 minutes. Even with prefer set to wait, the status may still return as starting. To ensure the video is fully generated, we need a way to track the request before attempting to retrieve it. The Set Prediction ID node captures the unique ID returned from the video generation request. This ID is required to check the video's status and fetch the final file once processing is complete. Set the mode to Manual Mapping. In the Fields to Set section, create a field named Prediction_ID. Use the shown expression to map it to Prediction ID, dynamically pulling the Prediction ID from the previous node's response. With the Prediction ID stored, we now introduce a wait node to pause the workflow and allow enough time for the video to be fully generated before retrieving it. The Retrieve AI video node fetches the final AI-generated video after processing is complete. Set the request method to get and use the API endpoint seen on the screen. This dynamically pulls the prediction ID stored earlier, ensuring we retrieve the correct video. Under headers, add authorization with bearer plus your replicate API token. No body parameters are needed. This request simply checks the status of the video and retrieves the output once available. Now that we have the AI-generated video, we're ready for the next step. The aggregate node organizes all generated video outputs into a single list, making it easier to process them in the next steps. Set aggregate to all item data into a single list to merge all retrieved video outputs into one collection. Input, output, and field, enter videos to store the combined data under this name. Under Include, select specified fields and add output to include only the final video links. The aggregate node organizes all generated video outputs into a single list, making it easier to process them in the next steps. With Step 4, Convert images into AI video clips complete, we now move on to Step 5, Prepare for Creatomate, ensuring all required assets are properly stored before assembling the final video. Before moving on to high-level Step 5, there's one crucial step in between, storing the AI-generated voiceover. Creatomate requires a hosted audio file, not a raw base 64 string. To achieve this, we upload the voiceover to Cloudinary, a cloud storage service optimized for media files and automation. The upload to Cloudinary node runs in parallel to video generation. It connects directly to the Generate AI voiceover node and later merges back with the video data before final processing. Here's how to set it up. Set the request method to post. Use the API endpoint shown on the screen, replacing your cloud name with your actual Cloudinary cloud name. Under Body Content Type, select Form URL Encoded. Add one parameter called File and use the exact expression shown on the screen for the value. Add another parameter called Upload Preset and set the value to ML_default. This enables unauthenticated uploads using Cloudinary's default preset. Once uploaded, Cloudinary returns a URL, which we'll later use to merge the voiceover with the video. The output from this upload to Cloudinary node will now be connected to the first node in high-level Step 5, Prepare for Creatomate. This next node is a merge node. The merge node combines the AI-generated video clips with the hosted voiceover file, ensuring all assets are structured for final assembly. Set the mode to Combine. Set Combine By to Position. This aligns each video with its corresponding audio file based on their order in the workflow. Set Number of Inputs to 2. This merges the video data from the aggregate node and the Cloudinary hosted voiceover. Enable Include any unpaired items. This ensures all available video and audio files are merged, even if some have missing pairs. Once executed, the merge node outputs a structured dataset containing both video and audio links, ready for the next processing step. This node generates a structured JSON file to format our AI-generated videos and audio for Creatomate, the automated video editing software. To streamline the setup, duplicate the existing timestamp and split script node, which also connects to Zero CodeKit. Right-click Timestamp and Split Script, select Duplicate, and move the new node next to the merge node. Open the duplicated node and rename it to Format for Creatomate. Set method to post and use the URL shown on the screen. Under headers, an auth key is already set from the duplication. For the body, set body content type to JSON. In Specify Body, select Using Fields below and add a field named Code. Switch to Expression mode, delete the existing script, and insert the new JSON formatting script. This script structures the video and audio files for Creatomate, ensuring videos play in the correct sequence. Audio aligns perfectly with visuals. Transition effects like fade-ins are applied. Once inserted, open the script in full screen mode to verify the formatting. As before, if you need the exact Python code used in this node, download the complete workflow from the link in the description. Now that the JSON is structured, the next step is setting a variable to isolate the code output before sending it to Creatomate. The filter data for Creatomate node extracts the formatted request from the previous step and stores it as a structured object for the final processing stage. Set the mode to manual mapping. In Fields to Set, create a field named Format for Creatomate. For the value, switch to Expression mode and enter the expression shown on the screen. This pulls the formatted JSON from the previous step and ensures only the necessary data is stored. By isolating the Creatomate request, we make sure that only the essential data moves forward in our automation. With this step complete, we're now finished with Step 5, Prepare for Creatomate. Next, we move on to the sixth and final high-level step, Final Render. The Submit Render Request node sends the finalized request to Creatomate, where the video rendering process is initiated. Set the method to post and enter the Creatomate API endpoint as the URL. Next, enable send headers to include authentication details in the request. Under Specify Headers, choose Using Fields below and add 2 header parameters. First, set authorization as the name. For the value, enter bearer followed by your own Creatomate API key. This ensures the request is authenticated. Next, add another header. Set the name to content type, and for the value, enter application/JSON. This tells Creatomate that the request contains structured data. Under body content type, select JSON as we are sending structured data. In Specify Body, choose Using Fields below. In Body Parameters, create a field named Source. For its value, switch to Expression mode and enter the expression seen on the screen. This ensures that the correctly formatted data from the previous step is sent directly to Creatomate. With this step, all structured video elements, including clips, transitions, and audio, are submitted for rendering. Since rendering takes time, we now introduce a wait node before proceeding to retrieve the final video. The rendering wait node pauses the workflow to allow Creatomate enough time to process and render the final video. Set resume after time interval. In wait amount, enter 120 and select seconds as the wait unit. This ensures that the workflow does not proceed prematurely before the rendering process is complete. Once the wait time has passed, we move on to retrieving the final video. The Retrieve Final Video node checks the status of the rendering process and fetches the completed video from Creatomate. Set the method to get and enter the Creatomate API endpoint as the URL, dynamically appending the render ID from the Submit Render Request node. Under headers, include the authorization key with your API token. Since this is a retrieval request, send body should be disabled. Once executed, this node provides the final rendered video URL, marking the completion of the entire automation process. To see the final result, copy the URL, paste it into your browser, and watch the completed video.
The truth about climate change is happening faster than we thought. Rising temperatures, extreme weather, and melting ice caps are just the start.
Congrats! You've built a fully automated AI video system, from script to final render, all inside n8n. AI tools are evolving fast, and the sooner you start, the more you'll stay ahead. Fine-tune this workflow, experiment, and make it your own. To make it even easier, you can download the full workflow via the link in the description. Use it as a reference, tweak it, and build on top of it. If this helped you, hit subscribe and like. That's the best way to let me know you want more. Also, drop a comment. What worked? What's missing? Got technical questions? I'm here to help. Let's keep building. See you in the next one.